Hello, I'm Hengkang, and in this final project, I have read two papers and learned some online resources, such as Stanford CS231 and courses. I have learned neural network, convolutional neural network, and graph CNN in Professor Sangela's group. Furthermore, I read another paper about one-class classification. So I will introduce what I have learned in the two parts. The first part is about the CNN. First, I introduced the architecture of the neural network, and then I compare some common activation functions like the sigmoid and its drawbacks, and then the tanh, and then the ReLU, including its advantages and disadvantages. And to prevent these disadvantages, we come up with another algorithm called liquid ReLU. And then I introduced what I have learned about convolutional neural network. First, I introduced the architecture. There are many convolution, ReLU, and pooling layers, and then come to the full connected layer, and then we can get the results. And next, I introduced the convolution layer in detail because this is the most important part in CNN. And I introduced the pooling layer and the full connected layer. Actually, this part is very similar to the general neural network, so I don't mention too much in this section. And then for the paper reading, I read a paper called Convolutional Neural Networks on Graph with First Localized Spectral Filtering. The main idea of the paper is that actually we have used CNNs in image, video, and sound recognition tasks, but they are all Euclidean space. And if we want to deal with some problems in social networks or brain images like the Professor Sangelas are doing, so in these situations we need to use another algorithms to get the results in the non-Euclidean Euclidean domain. And then the paper come up with an algorithm called GraphCNN. First, the algorithm designed a convolution filters for a graph, and then do the coarsening part, and finally do the pooling part. And I introduce the every part in details. But to be honest, this paper is a little bit difficult for the math part, and the typing the formulas is a little bit hard, so I just copy some parts of the paper here, and you can see. And for the part 2, I read another paper called Dual Minimax Probability Machines for One-Class Mobile Active Authentication. Actually, I read this paper in the latest biometric conference. And for the introduction, as we know, there are many devices using biometrics to do the active authentication, and then come up with the one-class classification problem. And I introduced first why we use the one-class classification to do the classification. Why we cannot use the two-class classification. And then I introduced a common algorithm called one-class SVM, and I compared with the single-class minimax probability machine. And then the max variance NPM is what the paper has done to find the hyperplane with a max variance. And then the paper combines both single class minimax probability machine and the max variance NPM together to get the single class dual NPM. And then for the results part, and we can see that the dual NPM performs best. So this is my report part, and then for the code, I write a small demo about graph CNN. First, I initialize the data just random, and then get the features by adjacent matrix, and here do the coarsening, and then use the graph CNN. Finally is the evaluation. So that's what I have done in this final project. Thank you.